And so this is exactly what we did at BrightNet. So we had these components, we have this link set up, but we essentially iterated on the design and implementation of this physical layer using our simulator. So we were able to encode all the noise models for the components. We were able to characterize the fibers and the links. We were able to encode the protocol logic that we need and set up essentially a BBM92 link simulation. So how does the simulation look under the hood? So in this framework, we want to be as close to reality as possible, right? We want to have a very useful simulator that not only simulates the ideal scenario, but is really accurate in simulating, real events that happen on the network, right? We talked about photon loss a lot. So on the right, you'll see our discrete event approach. So this is the way that the simulations actually run. So this source is emitting photons, right? So that there's a photon emission event at the top. In this case, okay, great. The photons made it all the way through and the photons were detected at Alice and Bob. However, we repeat this process again. And the next time, Bob's photon got lost on the way. And the next time, Alice's photon got lost on the way. So this is how the real network behaves in real operation. We're not considering, the ideal simulations here. This is a real, simulation of what we expect based on channels, based on the components that comprise the system. So this discrete event framework is really nice for not only modeling reality, but it's a virtual timeline too. So we can get down to, very granular time resolution down to picoseconds and, tracking individual photons and, looking at the state as it evolves.